Formal logic is the mathematical interpretation of logical reasoning. It's used primarily in fields of higher math, such as computer programming. The bad news is that most people find formal logic insanely boring and a complete waste of time. The good news is that for our purposes here, we really only have to extract a handful of principles. The first principle to understand is that virtually all arguments can be broken down into a series of if-then statements, where I say, if A happens, then B will happen. So a simple statement such as, Jerry will go home if he's not feeling well, could be rewritten in the standard form of formal logic as, if Jerry is sick, then he will go home. The pattern if A then B is considered the standard form for if-then statements. Usually, sentences and arguments aren't written in that simple standard form, so we have to translate the argument into standard form. These are a couple of common translations that are helpful to memorize, but they're best understood when we see them employed in actual arguments. In this argument we say, I'm going on vacation only if I get time off. And if you've memorized that A only if B is the same thing as if A, then B, then we could understand this question as, if I go on vacation, then you know I got time off, which is actually very different than, if I get time off, I'm going on vacation. Because the original argument doesn't say that if I get time off, I'm guaranteed to go on vacation. I might get time off and then decide to stay at home. But the argument does say that if I'm on vacation, then it's guaranteed that I actually got time off. And that subtle difference ends up being extremely important when you're choosing between two answer choices. Here's an argument using the word unless. And you should memorize that the form A unless B, that is the same thing as if not B, then A. So in this case, the argument that we can build a campfire unless it's raining could be written in the standard form as, if it's not raining, then we can build a campfire. So about a minute ago, I drew the distinction between if I go on vacation, then I get time off, and the reverse of that where I said if I get time off, then I'm going on vacation. Most arguments cannot be reversed in that way. In other words, the order of the if-then statement matters a lot. The exception is when I use the phrase if and only if. When you say if and only if, that actually means the argument can get reversed without consequence. So in this case, if we get married, then I know we are in love. And if we are in love, we're also going to get married. So when I use the phrase if and only if, then I can reverse the order of my if-then statement and it doesn't ruin the logic of the argument. But that is by far the exception. The vast majority of the time you cannot reverse the order of an if-then statement. I cannot say if A then B, therefore if B then A. Doing so is a logical fallacy known as affirming the conclusion or an improper reversal. And this fallacy is easily seen in a simple argument. If I say, if you're pregnant, then you must be a woman. That's fine. That's a true, good argument. But I cannot flip it. I cannot take that truth and then reverse it to say, therefore, if you're a woman, then you must be pregnant. Because clearly not every woman is pregnant all of the time. Here's one more, a little less obvious. You could say that in order to win the war, we're going to need a lot of soldiers. But it's a fallacy to flip that argument. If you have a lot of soldiers, that doesn't mean you're going to win the war. It might not look as obvious, but it really is the exact same argument as, if you're pregnant, then you're a woman, therefore if you're a woman, you must be pregnant. In this argument, the fallacy is a little bit more hidden, but it's still the same improper reversal we've seen before. The argument essentially says that if you get into Harvard, you must first get above a 165 on the LSAT. Therefore, since I scored above a 165, I'm certainly going to get into Harvard. On the surface, it might sound reasonable, but it's really the same thing as saying, if you're a woman, you must be pregnant. So we now know you can't flip the order of an argument without consequence. But you also can't assume the negative version of the argument. I cannot say, if A, then B, therefore, if not A, then not B. This fallacy is known as denying the premise or an improper negation. And again, it's really easy to see when we look at the example of pregnant women. While I can say that if you're pregnant, you must be a woman, that doesn't mean that if you're not pregnant, you're not a woman. So here's an example that actually happened to me. In high school, I had a 4.0 GPA and I was set to get a scholarship. But then in my last semester of high school, I got really lazy and I failed my ballroom dance class. And I thought, crap, now I can't get a scholarship. Which ended up not being true, but you can see the flaw in my reasoning. My argument was, if I have a 4.0, then I get a scholarship. Now I don't have a 4.0, so now I'm not going to get a scholarship. Which in my case ended up not being true, but it's still the same logical fallacy as saying, since you're not pregnant, you must not be a woman. Let's review what we've learned. If we have the argument, if A, then B, we cannot flip that argument. We cannot conclude, therefore, if B, then A. That's an improper reversal. We also can't take the same argument and negate it. We can't conclude, therefore, if not A, then not B. That's an improper negation. So you can't flip it and you can't negate it, but you actually can flip it and negate it. Logical reasoning does allow you to say, if A, then B, therefore, if we don't have B, then we don't have A. And again, if we resort to our example of being a pregnant woman, I know that if you're pregnant, then you're a woman. And if we exclude one episode of Oprah, we can usually say that if you're not a woman, then you're not pregnant. In this argument, the reasoning is in a funny order, but if we can translate the statements into standard form, we can see it actually utilizes good logic. We start off with the premise that all applications require an LSAT score to be accepted, which we could write as, if your application is accepted, then we know you have an LSAT score. But your application is actually missing your LSAT score, so your application has been rejected. In other words, if you don't have an LSAT score, then your application will not be accepted. So we flipped it, and we negated it, and that's okay. Another form of good logic is known as the transitive property, and that's the pattern where I say, if A, then B, and if B, then C, therefore I can conclude if A, then C. This is the way that good logic is supposed to work. And you can see it in a simple argument. If it snows tonight, I can't drive. If I can't drive, then I'm going to be late to work. Therefore, if it snows, I'm going to be late to work. Ideally, most logical reasoning should follow this pattern. Like I said in the beginning, the odds of you being tested directly on the principles of formal logic are quite low. However, understanding the difference between good and bad logic can help you choose between two otherwise equally tempting answers. Such as in this case, we start off with an argument that is pretty complicated, so we're going to try and rephrase this in standard form. And I'm going to do that by extracting a series of if-then statements. The first one I see is that if the population is going to be self-sustaining, the population must reach at least 250. Currently, we have 70 to 100 panthers, and if we keep the current habitat, we're not going to get any more. So I could rewrite this argument as, if the population is going to be self-sustaining, then I know we have at least 250 panthers. But if we have the current habitat, then we're not going to get 250 panthers. Using the contrapositive, I can flip and negate this top argument. I could rewrite that as, if we don't have 250, then the population is not going to be self-sustaining. Now I can use the transitive property, which would tell me that if we have the current habitat, and that means we don't have 250, and if we don't have 250, that means we're not self-sustaining, then I can conclude that if we have the current habitat, the population is not going to be self-sustaining. Now let's compare what we discovered to our answer choices. The first one says that if the population is more than 250, it will be self-sustaining. And that actually sounds very tempting because it has all of the right words from the argument. But remember, the argument actually said if we're going to be self-sustaining, then we have to have 250. But that doesn't mean we can conclude that if we have 250, we're going to be self-sustaining. Again, that's the same thing as saying, if you're a woman, you must be pregnant. The second answer choice says that unless we have a larger habitat, we're not going to be self-sustaining, which I could rewrite as, if we keep the current habitat, then they're not going to be self-sustaining. And that matches our prediction exactly.